What drifts toward us from the darkness between the stars? A solitary traveler crosses the invisible threshold of the solar system, its path untouched by planets, its origin older than our own sun. Astronomers watch with quiet astonishment, for they have seen this story before. Oumuamua was the first, a mysterious shard from another cradle of creation. But now another has come. This time it bears a name, 3I Atlas. It is not a comet like those born here. Its chemistry, its velocity, even its silence betray its alien bloodline. It is matter sculpted by a distant star, a relic carried across unimaginable gulfs of time and space. When its faint light touches the telescopes of Earth, it is more than photons. It is the voice of another system, whispering across the void. Scientists wonder if these wanderers are rare, or if they pass us often unnoticed in the dark. Each fragment may carry not just dust and frozen gases, but echoes of worlds unseen, oceans that never touched our skies, atmospheres that breathed different songs, elements arranged in ways unknown to Earth. And so the question lingers like a shadow across human thought. Are these fragments messages, scattered seeds of a galaxy alive with travelers, or are they silent drifters, indifferent to the civilizations that gaze upon them? The universe is speaking in fragments, each one a syllable, each one a reminder. We are not only observers of the cosmos, we are participants in its dialogue. And in the silence of interstellar messengers, humanity strains to listen for its place in that endless conversation. In the summer of 2019, beneath the restless skies of Hawaii, a pair of robotic eyes swept across the heavens. They belonged to the Atlas Survey, an array of modest telescopes whose mission was not to chase mysteries from other stars, but to guard the Earth against dangers closer to home. Atlas, the Asteroid Terrestrial Impact Last Alert System, was designed to find the faint flicker of asteroids that might one day cross Earth's path. Its task was vigilance, to catch threats before they caught us. Yet in its routine watchfulness, it stumbled upon something far more profound. In mid-December of that year, the survey detected a faint smear of light against the vast canvas of the sky. At first glance, it appeared ordinary, a comet, perhaps one of countless fragments of ice and dust that wander through the solar system. But its path was wrong. Its speed was wrong. Its story was not written in our sun's gravity. Astronomers looked again, tracing its arc across the stars. Calculations began, subtle refinements of orbital dynamics that told a tale stranger than fiction. Its orbit was hyperbolic, a trajectory not of return but of passage. Unlike the bound ellipses of planets and comets, this orbit had no tether. It was not of us. It was only through us this realization carried echoes. 2 years earlier, in 2017, the first messenger had been sighted, Oumuamua, a name that meant scout in Hawaiian, chosen to capture its role as the first recognized interstellar visitor to our system. Its elongated shape, its odd acceleration, its silence had ignited debates that still burned. Was it comet? Was it asteroid? Or was it something else entirely? A fragment of alien technology adrift between suns. The questions remained unanswered, but the story had barely begun when another voice entered the dialogue. In 2019, even before Atlas found its quarry, a second visitor had been discovered. Gennady Borisov, an amateur astronomer in Crimea, had spotted a comet that bore his name. Unlike Oumuamua, Borisov was unmistakably cometary, its coma and tail streaming from sublimating ice as it raced toward the sun. Its trajectory, too, was hyperbolic, its origins undeniably interstellar. Borisov was the second messenger, proof that Oumuamua was not a singular anomaly, but part of a greater truth. And then came Atlas, recording yet another fragment, another shard, from another world. This object, designated 3I Atlas, third interstellar, was faint and fragile, but no less profound. In less than 3 years, humanity had gone from none to 3. The galaxy was not silent. It was sending emissaries with regularity, and humanity was finally listening. The initial data painted a ghostly picture. Its brightness was weak, almost reluctant, as though the object were trying to conceal itself in the ocean of stars. Yet its trajectory betrayed its nature. With a velocity of over 30 kilometers per second relative to the sun, it was moving too fast to be bound. It had entered our system from the distant reaches of the constellation Lynx and would leave us forever, flung back into interstellar space. Astronomers debated what they were seeing. Was it cometary, with volatile ices sublimating as it neared the sun? Or was it more like an asteroid, a bare rock stripped of surface frost during its long exile in the void? The faint tail it seemed to shed suggested comet, yet its fragility was remarkable. Within months of discovery, even before it could reveal its secrets fully, 3I Atlas began to disintegrate. Its nucleus fragmented, its body unraveling like a parchment left too long in the wind. For scientists, the disintegration was both a loss and a gift. It robbed them of a chance to study a complete interstellar body in detail. Yet it offered glimpses of its interior, a rare window into material forged in another solar system, far from Earth's cradle. Each fragment that drifted away was a syllable in a language not of this star, but of another, and astronomers scrambled to record every fleeting detail before the messenger was gone. The discovery also stirred deeper questions. If in just 2 short years humanity had found 3 interstellar visitors, Oumuamua, Borisov, and now Atlas, then how many others had passed unrecognized through the ages? Were such wanderers common, perhaps drifting through our system every year unnoticed in the darkness? Or had humanity's instruments simply become sharp enough, sensitive enough to finally hear the whispers that had always been there? The astronomers who traced its course felt the weight of those questions. Each interstellar object was not merely a rock or a comet. It was a fragment of history, a shard of alien suns born in stellar nurseries we may never see. To hold such a piece, even briefly, was to hold the story of another world. And yet the moment was fleeting. Atlas's discovery would be gone as quickly as it had arrived, vanishing into the abyss like a dream upon waking. Still, the implications were profound. No longer could humanity believe that Oumuamua was a solitary accident, a once-in-history encounter. Instead, a pattern was forming, a lineage of messengers carried to us across the stars, each one different: Oumuamua enigmatic, Borisov luminous, Atlas fragile, but all speaking the same truth. The galaxy is not still. It breathes. It circulates its fragments, trading materials between systems like seeds scattered on the wind. When the telescopes in Hawaii first caught the faint shimmer of 3I Atlas, they could not have known they were adding a third verse to this growing cosmic poem. Yet the discovery shifted perspective. If these objects are common, then perhaps the galaxy itself is a web of exchange, a network of material migration. It raises a haunting possibility. Could the ingredients of life itself have spread this way, carried from star to star, world to world? Could Earth's oceans, its biochemistry, its very origins have been influenced by a fragment such as this, drifting in from a distant sun? The astronomers did not yet know, but as they plotted the trajectory of 3I Atlas, they saw not just numbers. They saw a story written in celestial mechanics, a narrative of exile and passage, and they understood that humanity stood at the beginning of a new era. For the first time, we were not only gazing outward, we were being gazed upon, visited, and perhaps reminded that the universe is far more connected than we once believed. So Atlas was fragile. It was temporary. But in its short-lived appearance, it reminded the watchers of Earth of something enduring. The cosmos does not send us silence. It sends us fragments, and each fragment, no matter how faint, carries the weight of alien suns. For centuries, the idea of an interstellar object drifting into the solar system belonged more to speculation than expectation. Astronomers imagined it in theory, fragments torn from alien systems exiled to drift among the stars. But theory was where it remained. The cosmos is vast beyond comprehension, and the space between stars is so empty that the chance of such an object wandering into our small, planetary neighborhood seemed impossibly slim. Calculations made in the 20th century painted a picture of extreme rarity. Even if every star cast countless shards into the void, the interstellar gulf would swallow nearly all of them. By those estimates, astronomers expected to wait centuries, perhaps millennia, before humanity would ever encounter one. To glimpse such a traveler was, in effect, to win a cosmic lottery. And yet, in the span of only 3 years, the impossible became routine. Oumuamua in 2017, Borisov in 2019, Atlas in 2019. 3 voices from 3 alien cradles, each one different, each one rewriting what we thought we knew. The shock was not only in their appearance, but in their nature. Oumuamua arrived first, its elongated form slipping silently past. refusing to display the tail of a comet yet accelerating as though some unseen force pushed it. Theories abounded. Icy hydrogen outgassing, a fragment of nitrogen ice, or something far stranger. No answer was conclusive. Its mystery remained intact as it vanished beyond reach. Then came Borisov, and its nature was clearer. A true comet, its coma and tail unmistakable. A piece of some distant icy world torn free and hurled into interstellar exile. Its arrival reassured some. Perhaps Oumuamua had only been an outlier. Borisov was comprehensible, familiar in its behavior even if alien in its origin. But Atlas, designated 3I, was something else again. This fragile visitor did not remain intact long enough for study. Within months of discovery, before its passage could be charted in detail, it began to disintegrate. Its nucleus fractured into smaller shards, scattering like a vessel dashed upon unseen shoals. The universe had delivered a messenger, only to see it unravel before it could speak. This unraveling was a mystery of its own. Comets often fragment, but 3I's disintegration was unusually swift. Its body seemed delicate, as if the long exile between stars had left it brittle. Perhaps its structure had been weakened by cosmic rays, battered by millennia of collisions with dust, or fractured by stresses of deep freeze and sudden heat. As it neared the sun, that fragility proved fatal. Astronomers watched its brightness flare, then fade, as its body crumbled into a cloud of fragments lost against the glare of starlight. The shock ran deeper than disappointment, for here was evidence that the galaxy is not a silent void, but a theater of ceaseless exchange. If 3 interstellar objects could be found in such quick succession, how many more had passed unnoticed? Too faint or too small for our telescopes to see. Perhaps Earth had always been brushed by the shadows of alien wanderers, their presence escaping us until now. This realization overturned long-held assumptions. What had been dismissed as nearly impossible was, in truth, inevitable. The galaxy, it seemed, was littered with fragments, shards of worlds, remnants of collisions, exiles from systems that may no longer exist. Every star might shed such travelers, scattering its debris like seeds into the night. Some of those seeds, in turn, would fall through the gravitational fields of other suns, skimming the edges of alien systems before resuming their endless flight. The scientific community found itself caught between awe and unease, at the grandeur of the cosmos revealed in new detail. Unease at the sudden recognition of how little was understood. If interstellar visitors are common, what else might they carry? Dust, molecules, even the building blocks of life itself, or perhaps fragments of catastrophe, echoes of planets that shattered long ago, their remains still wandering. The fragmentation of 3I Atlas deepened the mystery. Why had it fallen apart so swiftly? Was its structure unlike any comet known in the solar system? Was it composed of fragile ices rare to our sun's neighborhood yet common elsewhere? Its destruction prevented answers, yet the very act of breaking apart offered a different kind of revelation. Through disintegration, glimpses of its inner makeup were caught in scattered photons, a brief autopsy written in light. What little could be measured hinted at water ice, dust, and fragile volatiles. Nothing alien in essence, yet profoundly alien in origin. The shock of Atlas's demise forced astronomers to accept a humbling truth. These visitors may come often, but they will not linger. They are not ours to keep, but only to witness in passing. Their lifespans within our sight may be brief, their forms fragile, but their message is enduring. The universe is alive with fragments. Humanity, with its sharpened instruments, has finally begun to hear them. From this realization comes a quiet unease, one that lingers behind the science. If the galaxy is so crowded with fragments, then what does that mean for the story of life itself? Could the seeds of Earth's biology have been sown by a similar wanderer, billions of years ago, carrying molecules forged around another star? Or could our own planet's debris one day carry fragments of us into alien skies, seeding worlds we will never know? For now, the answers remain hidden. The fragments arrive, they whisper, and then they are gone. What remains is the shock, the recognition that the impossible is not only possible but common. Humanity stands in a galaxy where silence was an illusion. The void is alive with travelers, and each one is a reminder that we are not isolated. We are immersed in a cosmic river of fragments, flowing endlessly, carrying secrets we are only beginning to decipher. Atlas may have disintegrated, but its message endures. The universe does not withhold its wonders. It scatters them recklessly, abundantly across the dark. Humanity has only now begun to see. When the faint trace of 3I Atlas was first captured, astronomers turned not only their eyes but the full arsenal of human technology toward it. From the slopes of Mauna Loa and Haleakala, the twin telescopes of Atlas had sounded the alarm, but they could not work alone. Around the world, a chorus of instruments awoke. Ground-based observatories tracked the fragile light, while spaceborne telescopes joined the effort, each seeking to pull secrets from the brief messenger before it slipped away. Its orbit was the first key. As the data poured in, scientists traced its path against the stars, refining its trajectory night by night. The numbers told a story with stark clarity. This was no ellipse, no familiar orbit born of the sun's grip. It was hyperbolic, open, unbound, the celestial handwriting of exile. The object had entered the solar system from the direction of the constellation Lynx, crossing the vast frontier beyond Neptune, and it would never return. Its velocity, nearly 30 kilometers per second relative to the sun, was proof enough. This was an interstellar traveler. The calculations carried a deeper resonance. Somewhere beyond the reach of human telescopes, another star had given birth to this fragment. Perhaps it had once circled a world with oceans or deserts, moons or storms. Perhaps it had been forged in the accretion disk of a young star, flung outward by the migration of giant planets. Its journey was older than recorded history, a pilgrimage through the abyss that ended in our skies. Hubble, with its sharp gaze above Earth's atmosphere, was turned toward the fading glow. Ground-based telescopes from Chile to the Canary Islands joined in, measuring shifts in brightness as the object fractured. These light curves became a language of their own, encoding the death of the visitor in subtle variations of intensity. A sudden brightening revealed a fragment tearing free, sunlight glinting from freshly exposed ice. A slow fading signaled another piece crumbling into dust. To interpret these curves was to read the diary of disintegration. What emerged from the data was a portrait of fragility. Unlike Oumuamua, which resisted classification, or Borisov, whose cometary nature was bold and obvious, Atlas revealed itself as delicate, friable, a body held together only loosely by the gentlest bonds. The changing brightness suggested not one nucleus but many fragments diverging into separate trails. This was no solid asteroid of stone and metal, but a cluster of fragile icy material, the kind of substance that might have formed far from the warmth of any sun. The patterns of its breakup echoed those of comets born in our own Oort cloud. Yet there were differences, subtle but profound. The rate of its disintegration was too rapid, its cohesion too weak. Some speculated that cosmic rays and interstellar dust had battered its structure during its long exile, leaving it porous and brittle. Others suggested it might have been composed of exotic ices uncommon in the solar system, substances that vaporized too easily under the heat of our star, tearing the body apart. Each hypothesis was a window into another system's history. If it was ejected during the chaotic youth of its parent star, it might carry within it the chemistry of worlds that never came to be. If its weakness was due to long exposure in the void, it was a relic not just of its origin but of its journey. Either way, it spoke of processes both familiar and foreign, bridging human knowledge with the mysteries of alien suns. But the investigation carried a persistent frustration. Even as the instruments refined their data, the messenger was slipping away. The fragments were scattering, their light fading into the immensity of space. Every night brought diminishing returns, every calculation haunted by incompleteness. Scientists could measure, predict, extrapolate, but the object itself was dissolving before their eyes. The sense of loss was palpable. For a brief season, humanity had held a fragment of another world within reach. Telescopes had listened, instruments had strained, but before the story could be told in full, the pages were torn away by the void. What remained were only traces, light curves, orbital parameters, fading dust in a river of starlight. Yet even in incompleteness, the message was profound. The orbit revealed its interstellar birth. The breakup revealed its fragility. The brightness revealed its icy heart. Each clue was a fragment of truth, and together they painted a picture larger than themselves. The galaxy was not silent stone, but a sea alive with drifting shards. The scientists who pursued 3I Atlas knew they were reading only the first lines of a vast text, most of which remained hidden. But in those lines was enough to overturn assumptions, to widen horizons, to remind humanity that its telescopes were not just tools of curiosity. They were ears pressed against the walls of the universe, listening for whispers from beyond. As the last fragments of Atlas dissolved into invisibility, astronomers felt not only the frustration of unanswered questions, but the wonder of participation in something larger. They had glimpsed the handwriting of another star, even if only briefly. They had witnessed the fragility of a world not their own, and in that fleeting contact, humanity was reminded of its place, not as an isolated observer, but as a node in a cosmic network of exchange. The investigation was incomplete. The messenger had disintegrated before it could speak fully, but the silence it left behind was not empty. It was charged, alive with the recognition that there will be more. The galaxy does not send one messenger, nor two, nor three. It scatters countless fragments across the night. Humanity has only just begun to see them, and so the chapter closed, not with certainty but with humility. The fragments were gone, but the questions remained. The sense of incompleteness was itself a revelation. The universe had shown a glimpse, then withdrawn, leaving humanity suspended between awe and anticipation. For in the disintegration of Atlas lay not only an ending, but a promise. Others will come. Others are already on their way. The breakup of 3i Atlas did not bring clarity. It brought silence filled with questions. Why was this visitor so fragile, so ephemeral that it unraveled before its story could be told? Comets within our own solar system endure repeated journeys around the sun. They flare, fragment, and sometimes split, but they do not simply dissolve into dust the moment they arrive. Borisov had passed us in the same year, its icy body enduring the sun's heat, displaying a classic cometary tale as if to remind us of familiar rules. But Atlas was different. It came, it shattered, and it was gone, leaving only confusion in its wake. This difference was more than a detail. It was a mystery that deepened with each calculation. Perhaps Atlas had been born of fragile ices that never formed near our sun, substances like carbon monoxide or nitrogen, exotic volatiles that evaporate at temperatures far colder than those common in our neighborhood. If its parent system had forged it in the farthest reaches of a stellar nursery, its structure may have been tenuous, as brittle as frost underfoot. Or perhaps its long exile between the stars had hollowed it out, cosmic radiation eroding its core, until it was little more than a shell of dust and ice. Whatever the cause, the fragility of Atlas was a revelation. Not all interstellar objects would be like Borisov, sturdy and luminous. Some would be spectral, barely holding together like whispers of worlds already gone. To witness one was to realize how much might pass unseen. For if the galaxy can scatter fragments so delicate they unravel on arrival, then how many others drift by invisibly, too faint, too small, too fragile to announce themselves? Astronomers began to ask a troubling question. If in only a few years 3 interstellar visitors had been caught, then how many truly passed through our skies each decade, each century? Detection is a matter of probability, of technology, of timing. Humanity has only recently built eyes keen enough to notice such faint intruders. Before Oumuamua, the night sky had been scanned for comets and asteroids of local origin, not for wanderers from distant suns. The new sensitivity revealed a reality that had always been present but hidden. Planetary systems across the galaxy are not closed worlds. They are fountains ejecting debris endlessly into the dark. Planetary formation is a violent process. Giant planets migrate, scattering smaller worlds, hurling comets outward into exile. Collisions shatter moons, strip atmospheres, and fling remnants into trajectories that never return. For billions of years, every star has been a source of debris. Some fragments fall back, others escape entirely, carried into interstellar space to drift without end. The Milky Way is not a still sea of stars. It is a storm of fragments, a river of matter flowing unseen, and Earth sits within its current. Every so often a piece drifts close enough for us to see. But the unsettling truth is that for every Oumuamua, Borisov, or Atlas, countless others have slipped past unnoticed. Some may be small as grains of dust, entering our atmosphere as meteors without revealing their alien origin. Others may be vast mountain-sized bodies that pass silently in the depths of night, invisible except to instruments sensitive enough to trace their faint glimmer. Humanity is only now beginning to realize that the solar system is not a sealed sanctuary. It is porous, It is permeated by the wanderers of alien worlds. This realization carries with it both wonder and unease. For if comets and icy fragments pass by so often, then larger bodies must also exist. Astronomers speak of rogue planets, worlds torn from their parent stars wandering the galaxy unbound. The numbers are staggering. Studies suggest that rogue planets may outnumber the stars themselves. 1 billion orphaned Earths, 1 billion cold Jupiters drifting in the dark between suns. Most will never approach our system, but the knowledge that they exist transforms the imagination. If fragments can arrive, so too can giants. The possibility unsettles the mind. A comet's passing is fleeting, its influence negligible. But a rogue planet, such an encounter, however rare, would be catastrophic. Its gravity could distort orbits, fling worlds into chaos, or destabilize the delicate balance of the solar system. The thought is less a prediction than a reminder of scale. The galaxy is filled not only with beauty but with power, forces too immense to comprehend, objects too vast to imagine. Even without such extremes, the escalation of discovery has already reshaped our understanding. In only a short span, humanity has gone from imagining interstellar visitors as impossibly rare to realizing they are common, perhaps constant. The night sky is not only a dome of stars. It is a crossroads where fragments of alien suns brush against the gravity of our own. Earth itself drifts in this current, bathed not only in light from distant constellations but in the silent passage of matter born elsewhere. The philosophical weight of this truth is immense. For in every fragment lies the potential of connection. Each interstellar object is a messenger, a carrier of chemical stories written far away. Their ices may hold molecules shaped in alien seas. Their dust may contain minerals forged in unfamiliar furnaces. To study them is to touch the geology of other worlds, to hold in one's hand the memory of places never seen. And yet, the frustration remains. Atlas, so fragile, was gone before it could be fully studied. Its mystery deepened not in revelation but in absence. Astronomers strained to reconstruct its nature from fragments of data, from shifting brightness curves and vanishing dust. They glimpsed enough to know it was unlike Borisov, unlike Oumuamua, unlike anything local. But the full story dissolved with it. This incompleteness is itself a message. The universe does not yield its secrets easily. It offers glimpses, then takes them back, leaving humanity to wonder, to speculate, to prepare for the next. In the wake of Atlas, the search has intensified. New surveys are being designed, new telescopes planned, not to look only at stars and galaxies, but to catch the faintest flickers of alien messengers before they vanish. The escalation is both scientific and existential. Humanity is no longer an isolated observer of its own star system. It is a participant in a galactic exchange of matter, immersed in a sea of fragments drifting endlessly. Every fragment is a reminder that Earth itself is not fixed in solitude, but woven into the larger fabric of the Milky Way, and in this fabric lies both beauty and terror. Beauty, in the thought that the building blocks of life may travel freely, seeding possibility across the stars. Terror, in the recognition that larger forces, larger bodies drift with equal freedom, indifferent to the fragile stability of our world. The mystery deepens with each discovery. Oumuamua, enigmatic and silent. Borisov, luminous and familiar. Atlas, fragile and ghost-like. 3 messengers, 3 fragments of alien suns, each revealing not answers but questions. Together they form a pattern, one that suggests we are living not in a still universe but in a crossroads of endless motion. Humanity stands at that crossroads, watching, listening, straining to understand. And as the fragments pass, it is left with the most unsettling question of all. If such fragile visitors arrive often, if interstellar wanderers are common, then what else drifts unseen in the abyss? What larger shadows might one day emerge from the dark? For now there is no answer, only the knowledge that the galaxy is alive with travelers. Some small, some vast, some fragile, some enduring. All indifferent to us, yet all connected to us through the silent river of matter that flows among the stars. The mystery does not diminish. It escalates, it expands, and with each fragment that passes, humanity is reminded that it dwells not in a quiet solar system, but in the heart of a storm whose scale is the galaxy itself. When the fragments of 3I Atlas faded into invisibility, what remained was not clarity, but conjecture. Astronomers were left with shards of data and the ache of incompletion. From those traces, theories emerged. Some cautious, some daring, each an attempt to shape the silence into meaning. The most immediate explanation lay in its fragility. Atlas may have been a fragment of a long-period comet, a body that had wandered through interstellar darkness for eons, its icy structure weakened until it was porous as ash. When it entered the inner solar system, sunlight fell upon it for the first time in millions of years. The sudden warmth could have been catastrophic, vaporizing fragile volatiles deep inside, creating pressures that tore the nucleus apart. In this view, its destruction was natural, inevitable, the fate of a ghost that had lingered too long in the cold. Other theories looked farther back, to its birth. Perhaps Atlas was never whole to begin with. Planetary systems are violent nurseries where planets migrate, collide, and scatter debris outward into space. A young star surrounded by a disk of gas and dust can fling countless icy fragments into exile. Some fall inward and vanish in fire. Others are cast outward beyond escape velocity, ejected into interstellar space. Atlas could have been one of those exiles, an outcast from a system long forgotten, wandering the galaxy for billions of years before its final demise under our sun. Its fragility gave rise to another speculation, that its structure was not solid, but fluffy. Comets within our own system often resemble loosely bound aggregates, more like cosmic snowballs than rocks. Their densities are astonishingly low, sometimes less than that of water. Atlas may have been even more tenuous, a lattice of ice and dust so porous that the first taste of solar heat caused it to unravel. To hold such a body would have been to hold frost itself, delicate, impermanent, unable to endure. But the mystery deepened when contrasted with its predecessors. Oumuamua had not disintegrated. It had accelerated subtly, mysteriously, without a comet's tail to explain it. Some argued that hydrogen ice sublimation could have given it a push. Others suggested nitrogen ice, chipped from the surface of a Pluto-like world. And still others wondered if it was something else altogether. A shard of alien technology, a light sail adrift. The speculation was fringe, but it captured imaginations, for its strangeness invited questions beyond ordinary science. Borisov, by contrast, had been comprehensible. Its behavior matched that of comets known within our solar system, a tail streaming from ices sublimating in sunlight. It reassured scientists that not all interstellar visitors would be enigmas, but then came Atlas, shattering so swiftly that it could scarcely be studied. Oumuamua endured yet baffled. Borisov explained yet surprised. Atlas revealed yet dissolved. Each messenger was different. Each whispered a different truth. In that diversity lay the possibility of something larger. Perhaps these were not anomalies but representatives of a greater population. If planetary systems everywhere eject debris, then the galaxy itself may be filled with interstellar reservoirs, vast rivers of comets, icy streams of fragments drifting between stars. Some models suggest that for every star, trillions of such bodies exist, invisible in the dark. Each system may be surrounded not only by its own comets, but by the steady passage of alien fragments passing through. The image is staggering, the Milky Way not as a collection of isolated stars, but as a network of exchange. Debris streams flowing like invisible tides, carrying the chemistry of one world to another. If true, then interstellar objects are not rare messengers. They are constant companions, the unseen chorus of a galaxy alive with motion. Speculation stretches further still. If fragments like Atlas drift so freely, then the building blocks of life may also travel this way. The hypothesis of panspermia, the spread of life or prebiotic molecules across the galaxy, finds support in such possibilities. Complex organics have been detected on comets within our own system. If interstellar visitors carry similar cargo, then the seeds of life may cross the galaxy, delivered across light years by fragile icy messengers. And yet, the shadow of Oumuamua lingers. Its anomalous acceleration still resists simple explanation. Most astronomers lean toward natural causes, exotic ices, unusual shapes, subtle jets invisible to telescopes. But the lack of consensus leaves space for speculation. Could Oumuamua have been more than debris? Could some interstellar objects be artificial? Relics of technologies from civilizations unknown? The notion is speculative and most scientists remain skeptical. But the very fact that such discussions entered serious journals after Oumuamua's passing speaks to the depth of the mystery. Each new fragment invites not only science but imagination. Atlas's disintegration underscores a broader truth. These objects will not linger. They arrive, they whisper, and they vanish. Humanity is left with partial stories, fragments of fragments. Yet from these incomplete records, a pattern emerges, one that suggests planetary formation is not confined to any one system, but is a galactic phenomenon. The processes that shaped Earth and its neighbors are repeated around countless stars, scattering debris into the void. To study these visitors is to glimpse the universality of creation, the echo of alien worlds. In the end, the theories converge on a single recognition. Oumuamua, Borisov, Atlas, each different, each incomplete, yet together they testify to a galaxy in motion. A galaxy where planetary systems are not isolated islands but sources of endless exchange. Some fragments endure, others disintegrate, but all carry the handwriting of alien suns. The speculations reach outward, toward the unseen. If comets and icy shards arrive, could larger structures follow? Could rogue planets, even rogue moons, drift through our skies as well? Observations suggest the galaxy may be filled with such orphans, torn from their stars during chaotic migrations. They travel silently, invisible in the dark, awaiting only the faintest detection. The thought is both wonder and terror, that above us, hidden in the night, worlds without stars may already be passing by. Theories multiply, but certainty remains elusive. Atlas is gone, its fragments scattered, its truth hidden, yet in its absence it leaves a greater revelation, that the galaxy is alive with travelers, each one a mystery, each one a message. To pursue them is not only to study the unknown, it is to recognize that humanity lives within a cosmos that is restless, dynamic, ceaselessly in motion. The universe does not reveal its secrets in full, it reveals them in fragments, and from those fragments speculation rises, building bridges of thought across the abyss. Each theory is tentative, each model incomplete, but together they weave a deeper picture, a picture of a galaxy where worlds are forged, broken and scattered endlessly, where every star is a source of wanderers, and every fragment that passes is part of a story larger than itself. Oumuamua accelerated. Borisov endured. Atlas disintegrated. Each left behind questions, but together they left something greater, a recognition that the Milky Way is not quiet. It is a storm of fragments, a library of alien histories written in ice and dust, drifting endlessly through the dark. And humanity, with its telescopes and its questions, is only now beginning to read. The arrival of 3 interstellar visitors in such rapid succession has reshaped astronomy into a discipline of anticipation. Where once astronomers spoke of waiting centuries for such encounters, they now speak in years. The sky is no longer imagined as a static vault of stars and comets, but as a corridor, alive with travelers that sweep past in fleeting silence. The challenge now is not to wonder if they will come, but to be ready when they do. On the slopes of Cerro Pachon in Chile, a vast eye prepares to open. The Vera C. Rubin Observatory, scheduled to begin full operations within this decade, is unlike any telescope that has come before. With an enormous mirror and a camera the size of a small car, it is designed to capture the entire southern sky every few nights. Its mission is wide and ambitious, to map the motions of galaxies, trace dark energy, monitor asteroids, and probe the hidden structure of the universe. But among its most profound legacies will be the discovery of interstellar wanderers. Where previous surveys scanned narrow strips of sky, Rubin will sweep vast fields with unprecedented depth and cadence. It will see faint objects that once went unnoticed, tracking their paths against the star fields night after night. If interstellar fragments pass often, and evidence now suggests they do, Rubin will catch them. Some astronomers predict that dozens, perhaps even hundreds of such visitors will be revealed in the coming years. The galaxy, once imagined silent, will speak in voices too numerous to ignore, but to see is not enough. These messengers vanish quickly and the time to act is short. This is why the European Space Agency has prepared a sentinel of its own. The Comet interceptor, scheduled for launch in the late 2020s, will wait in the quiet emptiness near the Earth-Sun Lagrange point. A gravitational balance where spacecraft can linger with little fuel. There it will sleep silent until an object of interest is detected. When the next Oumuamua-like visitor is discovered, the interceptor will awaken. It will leave its post and chase, racing to intercept the messenger before it disappears. Its instruments are designed to probe composition, structure, and surface features, data never captured before from an interstellar fragment. It is a mission built not for one known target, but for a stranger yet unseen. Other instruments scattered across the Earth and orbiting above it also stand ready. The Hubble Space Telescope, nearing the twilight of its years, has already turned its gaze upon Oumuamua and Borisov. The James Webb Space Telescope, with its immense mirror and infrared vision, now offers an even sharper eye, capable of reading the faint spectra of distant comets, discerning the fingerprints of molecules and isotopes across vast distances. Ground-based observatories equipped with adaptive optics add their power, refining the trails of dust and light curves that reveal an object's inner secrets. Together they form a network of vigilance, a global web of eyes waiting for the next faint glimmer of alien stone or ice. What scientists seek is not only motion, but essence. Spectra can reveal the chemical bonds of water, carbon monoxide, methane, or exotic ices rare in our system. Isotopic ratios can speak of different stellar nurseries, marking whether the object was born in an environment hotter or colder, richer or poorer in certain elements than our own. By measuring these ratios, astronomers can trace the fingerprints of alien chemistry, comparing it to Earth's story, asking whether life's ingredients are common or rare across the stars. The urgency lies in time. Interstellar visitors move swiftly. They approach, blaze briefly in reflected sunlight, and fade into the abyss. Some survive only weeks before disintegrating, as Atlas did. Others, like Oumuamua, grow too faint within months, slipping beyond reach. The window for study is narrow, a fleeting corridor in which science must act with speed and precision. Missions must be ready before discovery. Telescopes must respond within hours, and international cooperation must be seamless. In this pursuit, astronomy becomes less a discipline of patience and more a discipline of readiness. Around the world, networks of astronomers collaborate across borders, sharing alerts the moment a potential interstellar trajectory is detected. Data streams from Hawaii to Europe, from Chile to South Africa, from orbiting telescopes to Antarctic stations. Each fragment is too precious to lose, too rare to study in isolation. The effort has become a collective endeavor of humanity itself, united in the recognition that these wanderers belong to no single nation, but to the galaxy, and that their secrets are fleeting gifts. The tools are evolving. Future concepts imagine spacecraft designed to launch not years after discovery, but within weeks. Small, nimble probes that can be dispatched rapidly toward a target, carrying cameras, spectrometers, and dust analyzers. Some propose missions stationed permanently in readiness, their trajectories adaptable, awaiting only the call to pursue. Others envision more ambitious goals, interceptors that could not only study but capture samples, returning grains of alien dust to Earth. To hold in human hands material from another star, this is no longer the dream of fiction. It is a goal written into scientific proposals, awaiting funding and fortune. Each new instrument brings the promise of deeper knowledge. To catch an interstellar visitor intact, to probe its structure before it disintegrates, to measure its chemistry in detail, these are steps toward answering questions older than science itself. Are the building blocks of life scattered freely through the galaxy? Do other systems forge comets with the same chemistry as ours? Or are they profoundly different? Do these fragments carry whispers of oceans we have never seen, atmospheres we will never breathe, worlds that exist only in exile? The search is no longer idle curiosity, it is urgency, sharpened by the fleeting nature of the messengers. Humanity stands at the beginning of an era when the galaxy is speaking more clearly, and the tools to listen are finally awakening. The Vera C. Rubin Observatory will map the chorus, the Comet Interceptor will give chase, Webb and its successors will read the light, while ground-based observatories will record the dance of disintegration. Together they form an orchestra of vigilance, tuned to catch the faintest note of alien matter before it fades. In the wake of Atlas, Borisov, and Oumuamua, science has been humbled by incompleteness. Each messenger left more questions than answers. But with new tools, humanity prepares to meet the next with readiness, to seize not fragments of truth but fuller stories. The galaxy is alive with travelers. The only question is whether we are prepared to listen before they vanish again into the abyss. When astronomers first traced the faint path of 3I Atlas across the night, they saw only an object, an icy fragment, fragile and temporary. But in the quiet weeks that followed, As it disintegrated into invisibility, the weight of its presence began to sink deeper. It was never just a comet. It was never only dust and ice. It was a whisper carried from another sun, a shard of alien history that had wandered longer than civilization itself. Each interstellar visitor reminds humanity that the universe is not still. These bodies are born in places unseen, clouds of gas collapsing into stars, disks of dust circling new worlds, collisions that shatter planets and scatter their remains. They carry with them the memory of that violence and creation, locked into their chemistry and their fragile bones. When they pass through our skies, they do more than reflect sunlight. They reflect possibility. For within their dust may lie molecules unlike any forged here, fragments of chemistry that speak of oceans and atmospheres alien to our own. Complex organics, the raw materials of biology, have already been found on comets of our solar system. Why not then on fragments from another? If worlds elsewhere were seeded with the same carbon-rich compounds, then life may not be an isolated accident. It may be the natural flowering of chemistry, scattered on the winds of interstellar debris. In this light, each visitor is more than messenger. It is mirror. It forces humanity to see itself as part of a vast exchange, a cosmic dialogue written not in words but in matter. Earth is not sealed away. It is immersed in a galactic current, a river of fragments drifting endlessly between stars. Our oceans may carry within them molecules that began their journey far away, delivered by messengers lost to history, long before eyes turned upward to watch. The philosophical weight of this truth is immense. For if fragments wander freely between systems, then no world is truly isolated. Every planetary system is porous, every sun part of a wider ecology of exchange. In such a galaxy, Earth is not unique in receiving visitors. It is one participant among billions, part of a network where stars trade dust and ice across the darkness. To recognize this is to accept that humanity's story has never been only Earth's. It has always been written into the fabric of the galaxy itself. And so the thought arises, how many times has Earth been visited? Not in centuries, but in aeons. How many fragments, unseen and unmeasured, have rained upon its surface? In the early days of oceans forming and continents rising, how many alien molecules fell into the seas, mixing with the planet's own chemistry, nudging it toward life? Perhaps without such messengers, Earth would be silent still. Perhaps the spark of biology required not only local fire, but the distant touch of alien dust. In this reflection lies both humility and wonder. Humanity often imagines itself alone, a singular story unfolding under one sun. But the evidence whispers otherwise. The galaxy is alive with fragments. Each one is a message, a reminder that creation is universal, not parochial. Life may not be Earth's solitary gift, but the consequence of a cosmos that refuses to remain separate. Oumuamua accelerated and vanished, leaving only questions. Borisov streamed past with a comet's familiar grace. Atlas disintegrated, too fragile to endure. Each one was different, yet all shared the same truth. The universe does not withhold its secrets. It scatters them recklessly, in wanderers that cross the gulfs between suns. They are fleeting, often lost before we can hear them fully, but their presence is undeniable. They tell us that we are not apart from the galaxy, but immersed in its restless tide. The final reflection is not scientific alone. It is existential. If matter drifts so freely between stars, then so too might meaning. Life's chemistry may be universal. The emergence of biology may be written into the laws of physics themselves, catalyzed by the exchange of fragments across billions of years. And if that is true, then humanity is not anomaly but echo, one voice in a chorus already present, waiting to be heard. The question that remains is not whether they come. They do. It is not whether they carry secrets. They always have. The question is whether we are ready to listen, to build the tools, to sharpen our vigilance, to capture their fleeting whispers before they are lost again to the dark. For the universe is not silent. It speaks in fragments. It speaks in wanderers. It speaks in shadows that pass briefly across our sky, reminding us that we are not alone in matter or in mystery. The closing truth is simple yet profound. We live in a galaxy alive with travelers, each one a story untold, each one a mirror held to our own existence. To study them is not only to understand other worlds, it is to understand ourselves. The universe speaks. The only question is, are we listening?